All right, 8.3, quadratic functions in standard form. ax squared plus bx plus c. That should look familiar when we factored in topic 7. That is exactly the same format we had. It's called standard form. So the y-intercept is very visible in this form. It's our c. Our axis of symmetry, remember that line that cuts the graph down the middle, it's not going to be as visible in this formula, or in this format, so we're going to have to use a formula that says negative b over 2a. So the negative of that middle term divide by 2 times my a value. And then the vertex, don't panic, that looks really awful. It's just the x value of the axis of symmetry, and then you're going to plug in the x value. All right, so graphing a quadratic in standard form, you're going to find that axis of symmetry, you're going to put that in the center, find your vertex, y-intercept, and or a couple other points, and their reflection. Connect them. Desmos makes this super duper easy. All right, so let's see. First example. So 2x squared plus 4x plus 3. So my a is 2, my b is 4, my c is 3. Okay, so we need to find our axis of symmetry first. That formula says negative b over 2 times a. So x equals negative 4 over 2 times a, 2. Negative 4 over 4 is negative 1. All right, so negative 1, that is my axis of symmetry. So right here, that's going to be the middle of my graph. So I'm going to make a table of values. And I'm going to put that negative 1 right smack in the middle, negative 1. And then same as usual, go a couple numbers smaller, a couple numbers larger. Now to find the corresponding y values, you're simply going to plug each x value in. So I would recommend going to Desmos, putting that f of x squared equals 2x squared plus 4x plus 3, put that in, press your gear, press your table, and get your y values. All right, so I have not done that in a little bit, so let's switch over to Desmos and get that done. Okay, so I've got Desmos. It's working very hard. There we go. Y equals 2x squared plus 4x plus 3. Okay, so I can see that's what it should look like. It's a parabola. I press my gear, press my table. And then reminder, those x values I want were negative 3, negative 2, negative 1, 0, and 1. So just change that table to reflect that. Negative 3, negative 2, negative 1, 0, 1, and 2. All right. Oops. I guess I didn't really need the 2. That was an extra value. But sure. All right. Write those values down, and then we will plot them. All right, so my y values were 9, 3, and 1, and 3, and 9. A good way to confirm that you have your vertex correct and your axis of symmetry is you should see that the points are mirror images of each other. So let's plot those. Negative 3, 9 is slightly off the graph. Negative 2, 3. Negative 1, 1. 0, 3. 1, 9. All right, there we go. All right, one more example with graphing. So now we've got one with a decimal. Same exact process. Here's my A, here's my B, here's my C. Axis of symmetry, negative B over 2 times A. So negative 3 over 2 times negative 0.75. Drop that into Desmos, and we get x equals 2. All right, so that's my axis of symmetry. So in my table, that 2 goes in the middle. And I went to Desmos. I found my y values, -4, -1.75, -1, -1.75, and -4. So again, those points are mirror images, and we plot. 1, -1.75, 2, -1. All right, there we go. All right, let's compare some properties here. So in this picture, I'll notice that I have fountain A that they give us the equation for. And then we have fountain B, which they give us a table of values. We want to know the vertex of each function. So the vertex looks to me like it's going to be the highest point because these are both going to have maximums. So that maximum for fountain A is going to happen at the axis of symmetry. So x equals -b, so -2, over 2 times my A, -1. So when my x value equals 1. So let's come back up to that function, f of x, but now we need f of 1, is -1 squared plus 2 times 1 plus 8. Okay, don't forget order of operations. -1 plus 2 is 1, 1 plus 8 is 9. Okay, so fountain A goes to a height of 9, I believe we're working in feet. Function B, the vertex, is the highest point, so my vertex is at -410. So which trajectory reaches a greater height in feet? Fountain B reaches a higher height. A height of 10 feet. Where fountain B, or fountain A rather, reaches only 9 feet. All right, there we go. And let's just wrap it all up. One last piece of information here. If I need information on the vertex, which format is going to be better? We're going to use the vertex form of the equation, which says a times x minus h squared plus k, and that vertex is h comma k. But now if I need the y-intercept, that is better off in standard form, which we talked about today, and that c value is your y-intercept, if it's in standard form. All right, there we go.